Hello and welcome to a further online learning session with the topic ClimaECO, Application Controller ACS, Functions and Solutions. My name is Thorsten Reibel from the Building Academy Smart Buildings, and I will present today. The session takes around 45 minutes. So let's talk about this application controller. It's a bit more product-oriented today, but of course also a lot of function solutions I would like to explain. But first of all, we should have a look into the device a bit, how it works. It's a bit different, but before we do this, let's have a look to our HVAC range, as always, so-called ClimaECO. Our complete range for heating, ventilation, air conditioning. It's a consistent solution, not only for room automation, but also for distribution, for assessing the generation part, for management and automation. So all these functions you need for a consistent solution. And as you know, we have a lot of different components, starting from any sensors to actuators, controller, and also the application controller. ACS is a very important component. And you see here on the right side, this product on top, responsible for management and automation. You know, we have done a lot of sessions, webinars, learning sessions. You find everything around this, what we have done already in our training and qualification database. So here an overview of not all, but many of these ClimaECO products. And today, as mentioned, we talk only about this one product, the application controller. But it's a comprehensive device. It's mainly related to HVAC functions, but not only, you will see. So I would like to open your eyes a bit for these possibilities of this component. I will not go in all the details, of course, and bore you with the details of any parameters, but to get a good overview and to get a good feeling for the main functions, I will show you something today. And don't forget, on Thursday this week, we have the topic again called then Practical Learning Session. And there I will show you everything live, what I present today more in theory. So it's even more worth for this product to see also the practical part. So the component itself, how does it work in principle related to all the other HVAC devices? First of all, this is a standard room climate or room temperature control. We do since the beginning of KNX, where you have any actuator or controller in distribution board for room temperature control. You have valves to control. You have here with this fan coil controller also fan to be controlled, and then additional inputs where you can connect, for example, a window contact to monitor the condensed water in the tray of a fan coil unit, or to calculate the dew point if existing. Of course, we have valve control, we have fan speed control. You can integrate any presence detector to change the operating mode depending on presence. And of course, any operating element, minimum operating element to change set points, fan speed, whatever, to see actual values. Here in this component, you can have also a controller, or you have it nowadays also possible in the components in the distribution board. So this is nothing new. Room, climate control. With the application controller you see on the left, which is responsible for management and automation, we can do even more. But in between this management level and the room level, we have two other levels. The distribution part, so different heating or cooling circuits normally exist in building. We have to control also something, the temperature, for example, the pump, and also the generation part. In principle, the chiller or the heater, the boiler, have to be assessed as well to create a consistent solution. So all these things we can do with our ClimaECO range, and the application controller is responsible to integrate everything, to do some superior task, and to implement the full solution. With the component itself, they can interact with each other. You see, everything is connected via the twisted pair KNX cable to each other. You have, of course, also connection, but not the total functionality, which is only possible with a central component here. And a further feature you see already here, it's not only a superior device, but also an interface for BACnet integration. So the very important BACnet protocol, we talk about this already a bit, is also here as an interface integrated. It's mainly for water-based heating and cooling, though of course also ventilation can be integrated. and typically for commercial projects, medium or small size ones. And you have all the necessary functions for this consistent solution here in the application controller. It's comprehensive, this device, and again, I would like to give you a good impression today what is all possible and how it works in principle. So having a look to the 4 main functions of this device, this overview is quite good. So I start with point number 1, automation functions. So we have so-called predefined functions, predefined logical functions integrated for different tasks. I will show you. It's a library of of functions up to 17 right now, which you can select directly in the ETS. So this is predefined, but we have also the option to create logic or intelligence or whatever you want, controller and comparison and mathematical functions by a freely programmable part integrated in this component. And if you know our logic controller ABA/S, then you know in principle the software part of this device as well. It's the same. So it's really the component ABS we integrated here as a freely programmable part here of the total software solution. Then we have a web user interface. The web user interface is just to assess not only the device itself, but all the functions behind which are assigned to this device, this application controller. Web user interface is a graphical interface where you can do something for testing, for monitoring, for maintenance, for commissioning, and it's very simple and automatically integrated. And last but not least, the BACnet interface. So we have a full BACnet IP to KNX twisted pair interface here integrated. All these 4 functions can work in parallel. It's independent of each other, but it's not only that you have to select 1 or 2 and then it's occupied this device. You can use everything in parallel, but of course it's also possible to say I don't need all these things, but only the BACnet interface would be also an option here. Of course, if you need only freely programmable logic, you can use directly the logic controller ABAS. So it's up to you, up to your project, what kind of functions you use here. So let's have a more specific look to these 4 detailed functions or specific functions. ASM is the abbreviation for application specific automation modules. These predefined software functions you select from a library, and then each function represent a specific functionality which can be executed by itself in the component, but can work also with other ASMs. You can combine different ASMs, these application-specific automation modules. You can add any free logic you would like to add here to create your complete solution. At the end, I have a small example to combine an ASM and predefined function with a freely programmable function. So what do you have? You select such a module, then you have so-called first of all, you have parameters. It's a software. You can parameterize something. You have group objects later. Depending on your parameter adjustment, you add also group addresses, of course. And if you go to the so-called linking view, then you see internal connections, or sockets so-called, where you can connect other ASMs. So that's for internal graphical programming of these different modules with each other. So I will explain this a bit later, not in details, but to get an overview here. That's very important. It's mainly related to HVAC functions. Not only, if you see later, for example, a trend ASM, trend is a data logger. You can use it for any values to be recorded in the device. Then the web user interface, what does it mean? It's an automatically created web user interface. You don't have to do anything. You enable only per data point or per function something in the component. And then later, by assessing this component via an IP address, you can look into functions of the device, into the device itself, in a very, let me say, user-friendly way. You see here, for example, on the right, the web user interface for a room. So we represent here a complete room for HVAC functions. So here with some more, not only heating and cooling, but also a radiator and fan coil. It's up to your programming what exists in your room, and then you might have 100 of these boxes here to represent 100 of your rooms, for example. So the layout is predefined. We cannot change this. Only you enable something here depending on your parameterization, but it's not like a visualization where you can create everything by your own. So it's a very simple, powerful user interface, can be used for commissioning or during commissioning phase, for maintenance, even as a small visualization in a special project. It's also possible to be used. Why not? It's not forbidden. But keep in mind, it's only more or less only related to HVAC functions. So any lighting, any shading solutions you cannot show here and operate and whatever. Yeah? So it can be a very user-friendly view, can be also a more technical view. You see it here on the left. I give you later some examples here for this web user interface. And latest on Thursday, if you could join as well, you see everything live, especially in the web user interface. So access again only via IP address with any browser, and then it's possible to see what you have done. So it's free of charge inside. You have to enable it only per function, and then you see something. Yeah, if you look later in the WebUI, you find for each function you have created a box here. Yeah. It's the same you have done later, or first of all in the ETS. So it represents directly what you've done in the ETS. Very often you see directly in such a box already an actual status or value. That's possible. You can change this value maybe, or if you click twice on such a component, or once, I think, on this component or this box, then a further window appears here with some more detailed view and some more detailed options to change something. Depends. So sometimes possible and sometimes not. You see here the box trend. Of course, you don't see anything here. You have to click on it and then you get a graphical overview of what you have recorded up to now. So that's later nice to see if we go directly to the web user interface on Thursday. Yeah, if we have not the predefined automation functions necessary, but freely programmable logic, we take also an ASM, an automation-specific application module, but it's called automation. And if you select this, you have not many parameters, only one button to open the logic editor. And then you come to this view here, a graphical environment to program or to create the graphical way any logical function, intelligent functions, time functions, controller, mathematical functions, everything can be linked with each other. Again, it's the same like our logic controller ABAS 1.2.1. No difference. It can work standalone as your own logic. You can link it later to the predefined ASMs to create your complete solution. We will see it later a bit. Yeah, and the BACnet gateway. We have an integrated BACnet IP to KNX to the gateway with bidirectional communication. So I can send from KNX to BACnet and BACnet can write into KNX devices. So it's a full KNX BACnet gateway. Yeah, and as it is also a BACnet device, it has also a certification behind. So it's a BACnet certified device. There are some documents behind you can find on our homepage just for your information. Not only KNX approved, but also BACnet approved component. Yeah, what else can we say about the product? We have the way to communicate to BACnet, to the web user interface, and to KNX, always in both directions. For BACnet, we talk BACnet IP. We use the Ethernet port in the device. To connect the web user interface means to connect your PC with a browser, needs also IP connection. But again, to KNX, we communicate with a traditional twisted pair connection terminal at the device. So it's not via IP, it's a twisted pair communication to all other related KNX devices, whatever you have. So this is a version with integrated BACnet interface called ACS 1.2.1, and if you don't need the BACnet interface, you can take the version ACS 1.1.1 and then you have all the functions except BACnet interface. So what else can be said around the hardware? Not that much. It's not our topic here to go in so many details, but You need a power supply, a very powerful device, cannot be supplied only by KNX. Two options, you use a 24-volt DC port here, or you use a LAN port when you have power over Ethernet. Then it's supplied by the LAN port. Yeah, the bus connection terminal we need for communication, as you know now, is behind the cover. We have a reset button here behind the labeling field. And the LAN port is not only for PoE, power over Ethernet if you want, it's also for connecting the WebUI and BACnet, of course, both is IP related. For the fast ETS application download, it's really recommended to have always an IP connection available. You save really time compared with programming via the bus connection terminal. And if you have your own logic created, we have a so-called online monitor available there. You see directly if you take action in your installation what happens with your logic. And for this purpose, you need also the IP connection. I show it to you also on Thursday in our practical demonstration. Yeah, we need an internal clock because we have a lot of time functions. We have this scheduler, we have this data logger, so all these time functions connected. For those who are more interested in the details of this product, you have two options. You can read the manual, of course, around 500 pages or more, I think. Or you download here from our ABB library the so-called training packages, a training package ClimaECO, which consists of a lot of documents around all the products, including exercises and some more. And also for the application controller, we have created 3 years ago around a more detailed presentation with short but in total complete explanation of the parameters. Makes it a bit easier than reading immediately the whole manual. So please have a look. You get later, as mentioned, still today, the PDF. There's a link behind here, and then you can download this if you want. Yeah, it's a KNX device. We have an ETS application, but remember, we have nowadays in powerful devices not only a standard ETS application with parameters, we have a so-called DCA, Device Configuration App. So it's an additional file you can download directly from our homepage. It's a product, but also from the App Store of the KNX organization. It's an app, so it's a product-related app. It's also an app, so on both locations available. You import this directly in the ETS, and then you have not the standard parameter view available, which is really limited to one parameter only. We have still parameter button here, but there's nothing behind. Everything is in the DCA. You see it here on the lower left side of the picture. And then you come to this more graphical environment where you parameterize everything around the functions of this application controller. Yeah, as mentioned, time functions are existing here. So how to synchronize the internal time, the internal clock. 3 options via BACnet. You can send the time via KNX from any time server in KNX. Like take a weather station, for example. And if you're IP or internet connected, you have also the option to use a network time protocol. Also here I come to some more details on Thursday related to our functions we will talk about. Yeah, let's come to some more details, not of all, but of some of these ASMs, application specific automation module. Yeah, a very heavy word, but take ASM as the abbreviation. And as mentioned, we have the automation. There's one ASM on top for logic, like the logic controller. Value is just to create data points. Data points to KNX, data points to BACnet. So you can parameterize a data point type. So the direction of communication can be parameterized, and then you can communicate to outside. Even to the WebUI, to the web user interface is done via these value ASMs. Link is nothing else but a connection to a URL, email, or file within the WebUI. And this morning I got the questions, what happens if I have more than one application controller in a project and I would like to operate both components? Is it possible in one WebUI? Not really. You access only one application controller at the same time, but you can create a button and via the IP address of the second application controller, you can jump directly to the next component. It's also easily possible. So then we have this room ASM, remember, just shown already, representation of the room in a graphical way with all HVAC functions behind related to the application controller, easy to operate, easy to see the actual status, quite user-friendly. Room set point is change of set points in the WebUI for room temperature. Then we have 4 very powerful ASMs. I don't go into much details today, too many details. It's for the distribution part and the generation part, heating and cooling, in total 4 modules. So heating distribution circuit, heat generator is a boiler, cooling distribution circuit, and chiller. Not the same, but very similar, very powerful, ASMs to create this consistent, complete solution from automation via generation to distribution in the room, thanks to the application controller. So I think I have only one or 2 slides later just to give you the first impression. Even in our practical demonstration next Thursday, I will not go here in too many details. It takes too much time. It's something for a real practical training. If you would like to see the complete solution here. So then we have a further option here, heating, cooling, changeover. If you would like to change in the WebUI between heating and cooling manually. It's also very user-friendly, more or less a kind of button here. And then we have all the schedulers. Scheduler for the WebUI means you have a time function running in the application controller, and you can adapt the time function. You can say when shall happen what inside the web user interface. For 3 different options, HVAC mode can be changed, comfort, standby, economy, building protection, at which time shall happen something in individual rooms, on off, and temperature means new set points. So 2 of them are mainly related to HVAC. On-off commands via a scheduler can be any function in principle. So 3 different ones, you see it here, WebUI, and the same is for BACnet available, you see it on the right. What does it mean in BACnet? BACnet, what is the difference? A BACnet scheduler means nothing else but change or adjustment of the timer of the scheduler is done on the BACnet level, not in KNX, so not via the application controller, but the execution of the time program is done in the application controller on the KNX side. So we separate execution and operation, adjustment of the time functions. Just if in case of any malfunction of the BACnet system, the time function is still running reliably on the KNX side. That's the target here. So you split this here if you want. There's a request very often for having such a function. And last but not least, this trend. I show you today some examples here. Trend or data logger is another name, just to record values, dynamic values over the time, to be displayed in the web user interface. So you see then in a graphical way, a line or bar graph, what you have recorded for any certain value. So how many trends or data logger you have? 50 in total. From 1 bit to 4 byte data point types can be used, and you can you can adjust the resolution here. How often you would like to record a value over a certain time. And as everything is stored in the components, the application controller, it's not any cloud solution here. Of course, we have any limitation in terms of memory, but you see around plus minus 20,000 values per data logger can be recorded. Of course, if you have a very often recording of the value, it's limited to some hours only, 24. But if you say, okay, every hour the value is okay for me, then it goes over 3 years. And of course, for this purpose, we need here also the time function. So shown in the web user interface, but can be exported, of course, for any XLS, also Excel sheet or PDF or whatever you want. So these are the 17 ASMs you have available. Okay, mainly HVAC related, not only, let's say, scheduler, data logger could be used anyhow, at least on-off scheduler here. Of course, these 4 functions are related to HVAC only, generation and distribution. But value or BACnet interfaces depend on the function behind, whether it's HVAC or anything else. For this purpose, the application controller can be used as well, independent of HVAC functions. Let's have a bit more detailed look into the BACnet interface to KNX. I've mentioned already a bit. So it's relatively simple to parameterize. You don't need any specific BACnet knowledge. It's very simple, and yeah, in one of the next slides I'll show you very simple, just one data point gateway functionality you can create here. Yeah, what can you do? Bidirectional communication, as mentioned. So BACnet can write into KNX easily, or you send a value, a status from KNX to BACnet. Both directions are possible. You can parameterize this in the ETS, in which direction you would like to go. If we send or deliver a value from KNX to BACnet, what does it mean? We are a so-called BACnet server, means we serve only the value to the BACnet system, but we do not process this value within the BACnet system. So it's like ordering a pizza, coming to your home. The pizza guy is ringing the bell and hand over to you the pizza. This is our KNX telegram in principle, but he does not serve the pizza on your table where you have some guests maybe. This you do by your own. You manage everything in your house by yourself. The same happens with the solution here. Our BACnet server cannot do anything in the BACnet system itself. So we are not a BACnet client. This has to be done by the BACnet system itself. So how many data points can be linked? Up to 500 with one application controller. Of course, it's not forbidden to use a second one. Keep in mind, this is not a pure only BACnet KNX gateway, the application controller. It's an additional function we have, beside all the others. But it's a full BACnet gateway to KNX with up to 500 data points. Just a practical example how to do this. Any data point from KNX linked to BACnet. Very simple, you go in the ETS, you select a so-called value ASM. Yeah, then you adjust first of all the data point from 1 bit to 4 byte. Remember, here is a 2 byte float, it's a temperature value. And then you can adjust the direction of communication to BACnet, read and writable to BACnet, or only readable. It's up to you. Yeah, and for the BACnet adjustments, very simple. You just can change the BACnet ID and the BACnet name for this data point. Yeah. The rest is not needed to change thanks to the adjustment I did already here. And then this value is available on the BACnet side. Of course, finally, to this group object created here out of this, you have to add the group address linked to the real KNX device behind. Any sensor, whatever you have, any actuator. This is, of course, is additionally necessary. But then, more or less, you have created your pure KNX to BACnet data point. And this you can do 500 times if you want. So name and ID will be proposed automatically from the application controller, but it's changeable if you need. Yeah, and then if you do this, you can still add WebUI integration, means the value you normally have on KNX down there, here in the group address recording. So group monitoring, and here you have a BACnet software showing the BACnet telegrams. Of course, they have the same value because they are linked with each other, and if you want the same, you can show also in the WebUI. So communication on 3 levels is possible with this component. Yeah, let's come to this ASM trend. It's a good module to show a bit in practice. In brackets, I've written here data logger. It's a kind of data logger. And how do you do this? It's again an ASM you select. Then you adjust a bit in the parameters. Remember the resolution, how often you would like to record, and how many of these trends you would like to have in one view later. You can name this. You can give or you have to add the data point, of course, as always, and then you can add here a second trend who you would like to show in parallel directly here. It's possible. So, and then I will show this on Thursday a bit more details. The linking view, because it's only a trend. It's an isolated function, first of all. I have to connect it to real values. Yeah, for example, I would like to record here, in my case, power of the wall box every 5 seconds, 24 hours, and every minute over a week. Yeah, and this again, any metering value, maybe it's coming from the energy actuator, from the energy module, whatever you have, even from switch actuators nowadays possible. and then I link it here internally, the linking view, and then the values are continuously available in the ASM trend to be recorded and to be shown in the web user interface, and if you want, you can export the values, as mentioned. So any value can be recorded here. Of course, for HVAC functions, typically we have set points, control values, temperatures, fan speeds. In a heating or cooling circuit, we have flow and return flow temperature. If you like to monitor this, record this, you can do it easily with this ASM trend. Yeah, some practical examples how it would look like. Here it's three trends more or less recorded in parallel, you see, and two trends which have the same data point type can be shown also in one graph here, more or less, with different colors. But this is another data point type. Control value is 1 byte, temperature is 2 byte. So what do we have here? Room temperature control situation with set point. It's the brown one or orange one here. The blue line here, it's ambient room temperature, actual temperature in the room, and this on below there, it's this control value. So you see, set point to 90 degrees, more or less stable. Now it jumps to 22 degrees. Set point change automatically, control value goes up, and also the temperature will rise. You stop heating, go down with the control value, and then it goes down slowly again. Yeah. And again, new set point means again new control value. And here, room temperature is below the set point, resulting in a new control value. You see it here as well. So you can easily monitor is everything working properly in your HVAC solution thanks to these data logger or trend function. That's very good and easier than looking through a lot of values you record anyhow in the group monitoring. Nobody will do this here. It's much more user-friendly. What is this here? Recording of outside temperature over a year. You see, it's over one complete year. Of course, not very detailed here. What's always possible later on Thursday, if you come to the practical learning session, we can do the following. We can zoom into a part of this time zone here. We say, okay, I would like to see directly in September only what happened. So I zoom here and then I see more detailed only for September, the value. That's also possible. So it's not static here, and also on the timeline below you can change here the resolution. What else do we have? Another recording with a line graph here of different temperatures here, outside, inside temperature, over one day maybe here, and so it's also possible. And last but not least, I recorded here the power of a refrigerator. Nothing to do with HVAC, just for your information, over the night. And you can see quite well such a refrigerator is working like this. It will be turned on maybe for half an hour or 40 minutes. The compressor is running, cooling down, and then it turned off. And then the temperature is rising slowly again, and anytime it will start again the compressor and turn on and off. So it's a quite good way to monitor a load, whether it's working properly, if it's not a continuous load, but a kind of two-step control load here, for example. But no problem, can be also recorded here with such a trend ASM. Good, let's come to the scheduler. It's also very user-friendly. What does it mean? Remember, we have principle the WebUI scheduler. I will concentrate on this with three options: HVAC mode, 1 byte, on, off, 1 bit, or temperature. So you select one scheduler. In principle, no parameters. In principle, let's say you don't connect anything here. The only thing you have to do, because in the group address view, a group object appears, and of course you have to add the group address of this load you would like to run time-wise. This is important, of course. The status of this scheduler can be also used internally for any further functions. So I connect internally to other logical functions something, but if it's a pure timer only, you don't do anything else but connecting the group address, then it works already. Of course, then in the WebUI you have to say when shall what happen. When shall be on, when shall be off. This you have to adjust there. So it's in principle a weekly timer. You adjust every day of the week with your time function. What happens if you have a special day? You can, of course, program an exception, a special day or a special period of day, holiday period, for example. You have another time program than normal. And in the calendar view, you have a good overview of all the time programs. Let's have a look to such a scheduler in the WebUI. So it's a very nice, user-friendly way to adjust time function in KNX, independent again of HVAC and whatever function. So you see here, if I click then in the WebUI on the scheduler, on off, no, this is a operating mode scheduler. You see operating mode, I can select comfort, standby, economy, building protection. How to do? Drag and drop. You click here on a day in the week, and then you take, okay, when shall be comfort? You move it here, and then of course you can start and end time, can be changed here. Plus minus, obviously your slider, very easy. So over the day you create your own time program, in this case with 4 options here, 4 different operating modes. For on-off, it's much easier. It's only on or off, of course. Yeah. And for the temperature scheduler, you add, of course, a value, which shall be at which time. Yeah, you do it for each day of the week. And if you say, no, I need special days, you go to exceptions here, create a period, and then you create your own time program. And finally, you can have an overview of all your days, what happens at each day over the year regarding the time program. I know we have many KNX devices having time functions, but another option here, and in my opinion, very user-friendly. So the BACnet scheduler, as mentioned, I don't go into details, it's just the same, but only time functions can be adjusted on BACnet. Finally, you have one parameter here, initial value can be programmed. You add again the group address in KNX, which shall be operated. But if you look to the web user interface, you see only the calendar with the time functions coming from BACnet, adjusted from BACnet originally. You can only view it here, but you cannot change. So only execution in the application controller, but no editing of the time function possible. Yeah, and then just a very small view only to one of these 4 very powerful ASMs used for distribution, heating or cooling distribution, and for the generation boiler or chiller. Again, this is something for a real practical training, and makes no sense to go step by step through these functions in theory. But the same principle, you select an ASM, you place it in your ETS, you have parameters, and you see already here, and that's not all, some more parameters to be adjusted. Yeah, and you have also in the linking view a lot of points for internal connection to create your own powerful functionality. And for which purpose do we need such an additional intelligence? Are the components like heating, cooling, circuit controller, or boiler chiller interface not powerful enough to create the logic by themselves? Yes, of course, they have also an ETS application, these dedicated devices, but to create the complete superior solution, we need an additional central software inside the application controller. And that's the task of these additional ASMs for the 4 different functions: heating, cooling, boiler chiller, or the heating or cooling circuit control. Yeah. So for example, you would like to change the curve flow temperature of the circuit depending on outside temperature. The typical solution in HVAC or in heating or cooling circuits, this curve is a graphical solution. You can change in the WebUI and adapt this curve by your own. You don't have to go to the hardware as a normal HVAC solutions to adjust something like this. You do it here directly in the web user interface. So it's also very user-friendly to assess this part in the web user interface instead of any other function or any other software. So a small look to understand, you see here, representing some functions of this ASM heating distribution circuit in the application controller. You see as a curve. This will be also visible in the application controller WebUI to change it. And you see the functional chain here. Outside temperature is an influencing parameter or function or value, plus some more will be processed. Out of this, I calculate the set point of the flow temperature of a circuit, you see here, and I control with the heating cooling circuit controller the mixing valve. Yeah? I measure the flow and return flow, and everything is in one total solution, and not only for one heating or cooling circuit, for many more of a complete project. Again, not more details right now, just to show you the flow, the communication flow, where is the application controller part of the solution. So, but at the end, I would like to come to a further real function I've created as a small example. Also here I will go in some more details on Thursday in the practical demonstration. What did I do here? Fan coil control with operation and displaying values in the WebUI, and additional logic for fresh air damper. What does it mean? So we have a simple fan coil controller with our operating element based on KNX, nothing else. Typically we control the valve and the fan speed, but normally we do not control how much fresh air has to come into the room, because this is normally done centrally from any other solution in a simple KNX solution first of all. And what did I do here? I said, oh no, in my pipe, air pipe into the room, I have the option to control also a damper, and this damper is related to fresh air coming from outside, for example. And I would like to control this the following way, that I say, depending on the air quality, I would like to open and close this air damper. So in my first very simple example, I do it only with open and close. So if the CO2 measurement done in the ABB Tenton here in my case, in the KNX device, exceeds 2500 ppm, then I open this air damper, so more fresh air comes into my room, and I have a better air quality. If it's going below 2500, I close again. How to do this? I need an additional logic, very simple, possible inside the application controller. So practically, I create an additional individual logic where I compare the measured CO2 value with a fixed value, 2500 ppm. And if it's greater, then I send a command, and I control, in this case, the additional relay of the fan coil controller, which is available in this device, to open and close the damper. It's a first step, very simple solution, and you see later my CO2 measurement comes into the device. This automation block here consists of the real automation I have done here. So this is a logic which is part of this box later. And output is here then the real output, the real command to the relay of the fan coil controller. Not perfectly done at the beginning. I can optimize this. I can say, okay, I need to hysteresis, of course. Not only 2500 ppm is a limit. Let's do it better. If it's exceeding 2500, I open the damper. If it goes below 2000 ppm, then it closes. So hysteresis is normal in such a two-step control. No problem. We can extend this logic here inside this ASM automation. Or you say, oh, it's a fixed value. No, I would like to have this as a variable value to be changed in the WebUI. No problem. Then it's not fixed. Then it's available to be changed via the WebUI. So dynamic thresholds I can program, I can adjust them. Or even better, I say, no, not open-close damper. I would like to have continuous control. So it's a damper controlled via 0 to 10 volt signal. So any steps in between open and close, I take an analog output and I have a real damper control here behind. You can do it with ABB Tenton because there is also directly CO2 control available. Or you use again the ASM with a PI controller as an additional software function here inside. Depends on the room temperature sensor you have. Not everybody has CO2 control inside. So also possible with an enhancement of this internal logic here. I will show it as mentioned on Thursday in practice a bit, but this is a combination of standard functions plus additional functions here, and can be also solved here, the situation. Good. So have a look to this, finally to this room ASM in the WebUI, and you see if I add this as a functionality also in the room ASM, I can do this, get an additional representation of the function here in the room ASM with an additional information about the position of the fresh air damper. Whether it's open or closed. So do not see only the room temperature, the control value, the operating mode, is it heating or cooling, and so on, and the CO2 value as well. No, you see also the position here of this fresh air damper. Yeah, and finally, my last slide here, group address assignment besides the standard group address assignments I don't show here, but this functionality is relatively simple. CO2 measured here by the ABB-Tenton device, sent to the application controller. Remember the logic we have to create. So then I have my logic, and out of the logic, compared with a fixed value or dynamic value, you send a command, damper open and close, to the relay of the fan coil controller. If you want, you send back a status from this fan coil controller back to the application controller to be shown in the room ASM, in the WebUI. Good. Yeah, that's in principle I wanted to show to you. Not everything, of course. I hope many of you can participate also on Thursday to see everything in practice, both with the ETS, both with BACnet gateway, both with web user additionally with web user interface. The same functions I have shown already here in theory. Maybe it helps even more to understand this component. As you know, I have always some final slides. I do it very fast today. You know our homepage where you find everything around the products, abb.com/KNX, our training qualification database with all the training stuff you have done already in the past. Everything is stored there and will be stored there. Our software repository, it's a Excel sheet which consists of all KNX ETS applications from the past and from the time right now. So it's a good, let me say, storage of all the ETS applications. If you need for any old product, anything, go there. You find it also on our homepage, available under additional material, download for KNX, and then software repository. And it will be always updated with new components if we have. So Light on Building comes now in October, I'm pretty sure, and looks good here in Europe at the moment with the Corona situation. So we have a real fair from the 2nd to the 6th of October in Frankfurt, as always, as in the over 20 last years. In addition, there will be a digital version of the Light on Building, kind of virtual fair, whatever it means. I'm not quite sure at the moment, but ABB, of course, is present live in hall number 12. Maybe we have a chance to see each other. Would be quite nice, I think, after so many times where we could not see each other, more or less. What is planned next? Is again, I repeat this on Thursday, the same topic in practice, functions and solutions of the application controller. And our next webinar will be then about the ETS 6, available for around half a year already. I did already a lot, so I will show still on Thursday everything in ETS 5, but it's not really different in terms of application controller at least. But we will show then on 1st of June what's new in the ETS 6. It's quite interesting in my opinion and has some good things inside. So you will be invited, of course. Then I say thank you for your participation and hope to see you maybe already on Thursday this week. Thank you. Bye-bye. Ciao.